Well, hello. How are you guys today? Today, or in this video, we're going to talk about what Python actually is. How was it, what does it look like when we think about the Python scripting language? Because the big question I kind of want to answer here is Python actually a programming language? Uh, let's find out. So, what I would like to discuss first begins with kind of how Python was created and what it's for. And then we're going to talk about the hierarchy of programming languages and what that kind of means. So, this is going to be part of the discussion of most other basic programming languages. How assembly, machine code works. We're not going to get into that really heavy. And then just to give you a general understanding of what you're learning about and why as you progress through this quarter. So we're going to begin with just kind of what Python is. What do we describe it as? We describe Python primarily as a scripting language, and but it can also be referred to as a programming language. However, that is incomplete, but is it? So let's get into that. So when we create a Python or some Python code, we create a Py file, and then the Py file is interpreted by a separate executable. It's another program that's built, and that program was built using C and C++. And what it does is it reads from top down, from the top of your script to the very bottom, from top down, each line of code and of your text file, and then it will execute the instructions you've placed in your text file. Now, why is that important? Well, and why is scripting important? Well, because we want Python to work on multiple different types of computers. We want it to work on a Macintosh. We want it to work on a Unix machine. We want it to work on a Windows machine. So what happens is that executable, that interpreter does the same job, but it does it differently for each architecture that it's actually installed on. So you have an interpreter that is Unix based. You have an interpreter that is Linux based. You have an interpreter executable. And I'm going to use that term interpreter and executable interchangeably, because what the interpreter is just another program. It's a program written in C and C++. So in a sense, when you're writing a script in Python, you're actually programming in C. Well, it's not C++. Take that. You're actually programming in C. Python was created with the C programming language. Or when I say created, not really, it's interpreted by the C programming language. So, what does that look like? It's easy for me to say, but I mean, come on, Mr. B, let's get a little bit more detail on this and kind of understand what that means. Well, what that means is somebody built this C program using a tool. Now, this is an example that I'm using, and I'm actually mixing C and C++ here a little bit. This source file would actually be an extension of .c. That's not important. What's important here is this command that I'm using. The printf command is actually a C command. And what the command is doing, and ignore this, this is just telling the window to pause so it doesn't disappear after it runs. What ends up happening is when I actually run this, it's different from an interpreter, because what this has to do is it has to compile these instructions down to machine code. So we look at kind of the hierarchy of programming languages. what ends up happening is the C and C++ goes down to the assembly language, and it's compiled to assembly first, and then from assembly it goes down to the machine code. Now, what does assembly look like? Assembly is very simple instructions like move from this memory location to another location, or process in this location information on, or move it from this register to the CPU. I don't want, because we're going to get too far into the weeds if I get into machine code, but let's just say that very complex lines of code like printf, let's say that complex lines of code, we can do like some steps with 3 lines of code in C or C++ that turns into maybe 10 lines of code. Because when you go from C++ or C, you're taking complex instructions and you're making them simpler. So it takes more code or more instructions to do the simplified 3 instructions that you give it. Because assembly is so simple. It's so simple, it's ridiculously simple. It makes it so difficult because you're doing complex things with very simple mechanics, such as putting information on the CPU, getting a result when the CPU processes that information, and then doing something with that result. So simple instructions in assembly then goes down to machine code. Now that 10 lines can turn into 20 in machine code, and machine code is literally just ones and zeros, with instructions, a memory location, an instruction, and a result. And so you get this high level line of code, or lines of instructions that convert. This 3 lines will convert to 10 lines in assembly, which then converts to 20 lines in machine code, and then that is finally compiled into your executable. So there's a lot of moving parts just working with C and C++. And guess what? All of these, what we would call programming languages, Java in its own right, and C#, we actually call programming languages when actually they're more the same brand as JavaScript and Python. They're scripting languages. They hide the script or the interpreter very well, and like C#, they call the interpreter the common language runtime. So they even obfuscate it and make it so it's less, they even hide pointers from you with these 2 languages. So they really dumb down how much code. And now let's just kind of look at that and say, hey, okay, Java was created with C++, C# was created with C++, Python, its interpreter is created with C. JavaScript, the same thing, its interpreter. So all these languages, guys, are all the same. They're all C and C++. Every single one of them was built by them. And the interpreter part of it, C# calls it the common language runtime. I can't remember what Java calls it, but in any case, JavaScript, we straight up say it's an interpreter. Python is an interpreter. So it's just a C program that reads your Python and converts the steps that you do. And let's say that 1 line of Python becomes 3 lines of C instructions, which becomes 10 lines of assembly, which is 20 lines of machine code. But that's an idea of why are we using these programming languages? Because we can write 1 line instead of 20. It's that simple. Because machine code and assembly are so simple, stupid, that it takes a lot of instructions to do anything complicated. And that's one reason why we use them. Another reason why is at this level, like with Python and especially JavaScript, we can catch errors and not trash the whole executable. So if JavaScript is reading a web page, we don't want the website to go down because that's making us money. We want it to happily ignore an error and move on to the next line. And so an interpreter is inherently better at doing that than C or C++, because if we have an error in C or C++, it crashes. The whole executable goes down. Therefore, the website trashes and stops working, and we're losing money because what's the most important thing about websites and website servers? AWS will tell you uptime. Because if that server is down, we are losing money. Now, Python, why is it important? Because a scientist only wants to write one line of code to get an answer instead of 3 or 10 or 20. A cybersecurity specialist only wants to write one line of code to fix an intrusion instead of 3, 10, or 20. Java and C#, likewise the same thing. Now, this is an oversimplification, but here's my point. They are all the same. Every single one of these languages is the same. And I would even go further than that and say every language out there, not everyone was created with C or C++. These four primarily were created with C and C++ at the very bottom. And regardless of what language you go to, they all behave the same. Python, a list in Python is an array in C and C++. A list in Python is an array in C# or an array in JavaScript. So even though we use different words in some other languages, it's all the same. So why is Python important? Well, it's got the error handling. But here's the thing about Python that makes it really cool, is because it's based on a C infrastructure, it's inherently quicker than like Java and C#, because Java and C# are based on more on C++. C is way faster than C++. So scientists can write just one line of code, get a very quick answer using Python. So what are the steps of the C, C++ assembly? What actually happens when I write a print command in Python and have it executed as a printf in C or C++? So let's look at that. So essentially what we have is, let's say that we have a print in Python in our Py file, and we can run this, and what'll happen is we have our hello output that I just ran it by hitting the play over here. What's going on behind those scenes? Well, the interpreter is fired up. Visual Studio knows to send this script to the executable that represents our interpreter when we installed the Python packages on our system. And that's why often you get some issues with choosing what interpreter to run when it comes to Python, because you can have different versions of the Python interpreter. Yeah, it gets kind of complicated sometimes. That different version is just an executable. It's a program written in C. So what does that program look like that actually reads my Python code and interprets it and outputs hello? Well, it looks like this. It's a compiled program, and I'll go up here and I'll compile the program by saying rebuild solution. What it does is it compiles it to assembly, and it takes that assembly and makes it into machine code, ones and zeros. And right here, rebuild all succeeded, that means it compiled. So if I look in the project directory, I will see the very outcome of my project, which is called project one, which is project1.exe. Let's go ahead and just delete this. See, it's gone now. Now I'm going to go over here and I'm going to say build, rebuild. There's my exe has been built. Here is the output from the compiler. project1.exe has succeeded. So I go down here and I see, oh, there's my project1.exe. Well, what does it do? Well, I can run it here, just outputs hello. I can run it from the integrated development environment, which is what this is, and it will pop up and output here. Okay, and that system pause, just ignore. That's specific for Windows. That's just to make sure that the black screen doesn't disappear on us, or the console output. So what is actually happening? Well, the exe that we built, let's call this the interpreter. The Python interpreter. It's just a program. And what it does is it opens your Py file. And it starts at the top of your Py file. So it opens up your Py file and it starts at the top and it reads each line of code. Now when it gets here, it says, oh, I've got a print command. Well, then what does it do? Well, if I see a print command, if I see a print hello, and there will be an actual if statement in here. And it'll be something like if, and this is the input, it'll be something like this. If input equals, and this is very, very loose because you would have to actually do a string compare when you're working with C. If input is equal to, or if print, or if the line I'm looking at, if the line or IC is equal to print, then print the input. And what they'll do is they just literally call the printf command that is built for the C programming language, and they'll put your input here and they will command it to print the input that you've put in your program, which is here. So it's just a wrapper, guys. That's all it is. It just reads your text file from top down and completes the print command if it sees the print command. And if it sees the print command, then it prints what you've told it using the C's print command called printf. And I'm just injecting hello right into there because we're all that work that we would have to do where I'm using kind of pseudocode here. We would have to begin writing the actual Python language, which we're not going to do. But this is what it looks like. This is how it's done. And this is what an interpreter is. So when I refer to programming languages and I talk about syntax and I kind of discuss all the different types of programming languages out there, and maybe sometimes I get confused about which program language I'm working in, or I use Google to reference whatever tool that I need to use, such as a printf command or a print command or whatever language it is, it doesn't matter. They're all the same. They're all based on a common infrastructure. And when we call, when we're using Python and we have a C program that's our interpreter, we call this wrapping. We wrap it up in the Python language, and C is just a wrapper. that wraps over the Python language and implements it using C. Now, this is very much an oversimplification of some complex behaviors, but nevertheless, it's true. It's the way the technology is built. And the reason being for that is, why should we be writing 20 lines of code when we can just write one? So, and then also you're wondering why it gets infuriating to write programs. And then you think about all the crap that you're on top of and to make sure that it works correctly. Not only are you working on hardware built by many different manufacturers, but you're working with software that's built on top of many different layers. And sometimes if you get an error in Python, it'll output the C error, like standard IO error, blah, blah, blah. And basically what it's saying is, if you see like a standard IO error, that means standard input output library using the C programming language. So there was a problem when in some kind of step between when C read your code, or the C interpreter read your code in Python and tried to implement it in either input or output. And you'll see those weird outputs when you try to run your Python code. It'll show up and read it down here, and it'll be like STDIO error. That's a C error, guys. And the interpreter is just returning the error that the C programming language does when it's wrapping your code and implementing the instructions. So now we kind of have an idea of what we're actually working with and doing. Now the benefits are obvious. The retraction is the fact that some people will discuss this hierarchy and how Java or JavaScript run really slow, or C# runs really slow, because it's on top of a bunch of bloat. In fact, Java and C# are very bloaty libraries. Python is somewhat bloaty, but since it uses C as the base, it's actually considered fast. And so I also refer to Python as a shorthand programming language for C. I kind of think of it as just C shorthand, a C shorthand programming. Kind of like writing shorthand when people learned when there was no typewriters and they needed to write a lot of information on a page of paper, but they couldn't keep up with somebody that was talking. They came up with a separate language or a separate way of writing called shorthand. And because they could write with less characters to get the same idea across. The same thing as shorthand is what the interpreter is we're writing with less stuff to get the same idea and steps across. 1 line to 3 to 10 to 20 at the very bottom. And that's kind of the very basics of it. So now that you know what an interpreter is and why we use interpreters like JavaScript to keep uptime, Python so scientists can just focus on getting the answer instead of writing a whole bunch of code, cybersecurity analysts that need an answer to stop an intrusion quick. Another thing that Python was really good at, let me think about, I just had it on the tip of my tongue, but data mining, web scraping with the curl library. Oh, this is a good one. Google uses or started using what we call binary trees to change the world. And it used to be I would have to, when I used the pre-search tool, pre-Google search tool, one of them was called Alta Vista, I would put in my search into the computer, I would hit the enter key, and the computer, my search term would search for what I was looking for. I literally go grab a cup of coffee, come back, and the search wasn't done yet. When Google came out, I put in my search term, and bam, the answer would pop up without even me getting out of my seat. I couldn't believe it. It was a showstopper. It changed everything. It changed the world. They wrote that with Python, guys, because if you're doing something complex that changes the world, you're going to do it with one line of code instead of 20. Because if you're doing something so complex and you get into the weeds of dealing with 20 lines of code, if I'm dealing with something very complex, I want it to be as simple as possible. So I'm going to deal, and I'm going to do it in Python. That makes it a winner in my book, because I can do things that are very complex that have not been done before with very little instructions compared to a lot of instructions. So yes, Python changed the world. And Google is one of the very first implementations for it. And that's one of the reasons why it's still used today. Okay, thank you guys. We will continue on our journey in other videos. Bye-bye.